hope you enjoyed your dinner last night. And for some of you, your beer sessions afterwards. But I'm glad you made it back, or at least some of you. And I hope you also have your first cup of coffee and ready for today's session. So I think we're all ready. Let's get started. We have an exciting session this morning. We'll have one keynote speaker and a lightning talk. So during the Q&A, I would ask the lightning talk speakers to line up. But first, let me introduce our keynote speaker. I have to read my note because I didn't memorize all of them. Dr. Laura Nielsen, she's an associate professor of sociology at the University of British Columbia, where she also directs the Center for Computational Social Science. Dr. Nielsen received her PhD in sociology from University of California, Berkeley, and she used computational method to study social movements, gender, culture, and institutions, as well as to advance computational text and analysis techniques. Her work has appeared in leading journals, including the American Journal of Sociology, American Sociological Review, and Sociological Methods and Research. She also serves the field through editorial roles, like Journal of Poetics, ACTA Sociology, and American Journal of Sociology. Please join me in welcoming Dr. Nielsen.
Okay, so when Peter and Mark asked me to speak about qualitative methods, I thought a lot about what I'd want to say today. How can I convince computational social scientists to use qualitative methods, or how can I convince qualitative social scientists to use computational methods? And when I was reviewing notes in the field, I decided I don't need to tell you anything. I can just show you what the field is, what the field has done over the past 10, 15 years, and how it's matured, and you can then decide for yourself if this is useful for you. So that's what I'm going to do. And one of my motivations for this is, as I've been sitting in on talks today and reading stuff from the field, a lot of what we do is implicitly in computational social science is implicitly drawing on qualitative methodology, and we don't always make it explicit. So a big thing that we do in computational social science is we take this messy text or images and audio and we turn it into measurable variables that then we analyze. And that moment of turning text or images or audio into analyzable variables is fundamentally a qualitative moment. And we draw on these qualitative methodologies to do that, but we don't always say that we are. So my invitation here to you all is maybe some of you will start to make that more explicit in what you do, and I think that will strengthen the field as a whole going forward. So I'll do a history and survey of the field. This is, of course, from my perspective. You could tell this story many different ways, and as I do so, I want to foreground some key debates and unresolved questions that animate qualitative people when they talk about this stuff, and think about new opportunities for the future. Lots of stuff happening in this field. All right, I'm going to do so in 4 sections. Epistemology, it all starts with epistemology. Applications, I think sometimes we back into our epistemology through our applications, so I want to foreground epistemology. I'm going to go a bit deeper into ontology and then think about the future. And these kind of 4 sections came out inductively as I was exploring the field. All right, epistemology. We have a maturing epistemology in qualitative computational methods. I don't know what to call this subfield, so I'm going to call it qualitative computational methods. The 4 I'm going to cover today are cultural cartography, and I'll put a little asterisk on that at the end. Grounded in abductive theory, pragmatism, and realism. So I think these are 4 epistemologies that are fundamentally rooted in qualitative methodology and are often used in computational social science. So cultural cartography, which isn't really an epistemology, but I want to talk about it because one of the first papers published in this field, in my field of sociology, was Monica Lee and John Levy Martin way back in 2013, where they critiqued qualitative social science for labeling things too much. So when you code text in qualitative social science, you label bits of text according to what they mean. And this is kind of a heavy-handed approach according to these scholars. And so they said, instead of coding things, we should just present a map of the data. And in this case, it was a semantic network. And so you make a claim, you present a map of the data, and you invite the readers to interpret along with you rather than trying to interpret it for them. And they're using semantic networks. This was picked up by Goldenstein and Poshman, where they updated it using topic models and semantic triplets to map out the world of corporate responsibility in newspapers. The text isn't important, the map is important here. And then Dustin Stoltz and Marshall Taylor updated this for word embeddings. So this has been updated to say, we just present a map. That's what we're doing, is we're reducing the data into something that the reader can interpret along with us. Grounded theory takes a bit of a different approach. So this was trying to update the decades-old epistemology proposed in the 1960s to make it kind of a more principled approach to extracting themes from text. I presented this in 2017, published in 2020, where I said, okay, we can use computational methods to identify patterns, we can do deep reading to confirm those patterns, and then we can confirm broad patterns using additional methods. And since then, this has been updated and critiqued and pushed. And so this paper by Carlson and Rollund, they said we shouldn't be machine-led, we should be human-led. And computational grounded theory is too much of the machine, not enough human. So they said, put more of the human back in there. And other publications had said we need to get much more closer to the roots of grounded theory. So the memo writing, the constant comparison, gathering more data. So there's been a lot of developments in this field to make it much more closer to the traditional grounded theory approach. The other approach here, which pushes back against grounded theory a bit, is abductive theory. And this is really championed by people like James Evans and Jacob Foster in some ways. And the idea here is you should come in with a really strong theory of what you expect to find, but be open to surprises. And it's that moment of surprise where the data doesn't match what you expect, where you are like, whoa, that's not what I thought. That's the moment, that's the theory building moment there. So abductive theory, come in with a theory, but be open to surprise. So Tavery and Timmermans proposed this for ethnography, so a qualitative method in ethnography, that when you go out into the field, you should be open to being challenged by the field that you're going into. And they said, and Philip Brandt helped with this, we can do that with digital methods, with computational methods, right? Be open to surprises by your data. So they were looking at taxi, when people take breaks in taxi service in New York City, and noticed that right at sunset, a bunch of people were taking breaks, suggesting that it's a religious thing, perhaps, in that time. So James Evans and Jacob Foster, they really pushed this in an awesome paper called Alien Robots, where they said lean into the fact that machines interpret or parse text differently than humans. They're not replicating what humans do, they do it differently, and that's the powerful moment that machines can give us, computational methods can give us. So this is just from Shakespeare, but they really want to say, like, this is an alien, this thing that we use, this computer is an alien, and that's super powerful, and we should lean into that. Enzel here and Mood, they did this in a quantitative way. So this is an example of quantitative social scientists drawing from qualitative epistemology. They used the multiverse analysis to rethink stratification and income mobility, generational income mobility. So instead of saying, here are my variables, here's my hypothesis, they gathered a bunch of data and they said, given reasonable assumptions, reasonable ways of parsing our data, what is the full range of verses, right? What is the multiverse of ways that income mobility can happen or not happen? And so they noted things like the woman's wage is actually really important for income immobility at the time. So multiverse analysis and quantitative, but it's that moment of surprise where you see something that you don't expect to see. Pragmatism is similar, and I see this more often in Europe than I do in North America, the pragmatist approach, although the roots are in the Chicago School in the United States. So the pragmatist approach is the moment of surprise that really pushes theory forward should be when you put it into practice. You actually try something and you put it into practice, and when it clashes with the world, the real world that you put into practice, it's that clashing moment which forces us to update our theory. So J.P. Pardoguerra and his colleague Pawa, they proposed this extended computational case method where they did ethnography, they did participant observation and interviews of scholars in Britain, and then they did a computational analysis of like scholarship, and they actually presented the computational analysis to the ethnographic participants, the interview participants, and they said, whoa, that's not our experience at all. So it was that moment of presenting the computational results to people who were living that experience, and when they clashed, that helped them push theory forward there. So it's that kind of pragmatic moment that happened. And you see this really strongly in some of the work coming out of Sodas and University of Copenhagen, where they really try to put computational methods into practice and see when it clashes. So this is a piece where they really present this theory, machine anthropology, or friction by machine. So they talk about emic and etic friction. So this is really deeply rooted in ethnography. The pragmatist approach to ethnography is you need to be open to your participants having a completely different worldview than you, and you need to update your worldview when you kind of hit that in the ethnographic field. We can again do that with machines, right? When the machines kind of butt up against our worldview, that we can update that. And the big point here is that for many, many, many years, qualitative social scientists have been saying we can use computational methods to do things bigger, to do things faster, to scale up what we do. And they said, no, we can slow it down. We could force ourselves to think harder and do things slower. And that's what we should be doing. So don't enable more, faster, bigger. Go slower, more friction. And it's that moment of friction that's really powerful there. And then we have the realist approach. And this is going to raise some eyebrows from the qualitative social scientists in the room. Some people don't want to claim this approach, but it is a really popular approach, probably rooted in North America. But Corey Abramson really articulated this in 2018 with computational ethnography. So when you think about realist ethnography, the idea is you go out in the field and you just describe your experiences. You describe what's there. You're just, hey, this is what happened. And so his claim, him and his team's claim, was we can use computational ethnography to help address some of the criticisms, so scalability, transparency, replicability. So we can make it more positivist, essentially. I'm not using the word positivist, but it is positivist there. I have some work here. I'm not sure I would really put this in the realist category, but thinking about how we can use LLMs in collaboration with humans to do what classically qualitative social scientists do, which is code bits of text. We saw this with Brandon's keynote yesterday and Lisa's a little bit. So just thinking about using large language models just to do what we've always done, but do it a little bit better there. And I put an asterisk on the cultural cartography because I actually think they're here. They're kind of in the realist approach. They just want to describe and present the world to you. So I think when we do computational social scientists, we're often slotting ourselves into one of these epistemologies without making that explicit. So I'm inviting us all to think about when we try and identify patterns, what we're doing there. There are some very animated debates. If you're not in this subfield, you might not be aware of these debates, but the debates around epistemology, theory before or after. This is really, really important to some people. When you gather data, you go out in the field, do you have an idea of what you think will happen, right? This is the kind of abductive theory approach. Or do you want to have a blank slate and allow patterns to completely emerge from the data, which is the classic grounded theory approach? This really animates people. Can you have a blank slate at all? Should you? Should you not? Should you have a theory? So think about that as you're doing your work. This also really animates people and animated a lot of the early qualitative methods. Do you label patterns or do you just map them? So when you do a topic model, do you label the topic? Because as soon as you label that topic, that's what your readers are going to think. They're going to think your label, not what the topic is. And topics are just clusters of words, right? When you put a label on it, you're adding an interpretive level to it, which, according to some people, is essential. We can't interpret topics unless you interpret it as a researcher. For some people, that's being over heavy-handed, and you shouldn't do that because now you're adding your perspective onto the data that the readers may not. It will influence the way the readers see it. And so this is a really important moment as well. And then who's the driver? Is it human or machine? Should this be really a human-driven analysis and we're just using computational methods to expand it or do it deeper? Or really should we be allowing the machine do it because we have so many biases, implicit biases in our head, we should really be allowing the machine to cut through those biases, computational methods. Again, very animated debate here. I don't think this is a debate, but I just wanted to put this up there. Should we be trying to go faster, bigger, more, which computer science tends to do, move fast, or should we be slowing down, using these methods to slow us down? I want to maybe invite us all to go a little bit slower and think deeper here. So epistemology ideally comes first, and then practical applications. You decide how you think you know what you want to know, how you will know what you want to know, and then you go for it. Usually it's the opposite in practice. You back into your epistemology. But the practical applications I'll go through pretty quickly here. The way that I see it done in qualitative computational methods. We can discover patterns using computational methods, evaluate themes, refine our concepts, and collect primary data, and in some cases synthetic data, but I'm going to put an asterisk there as well. Discovering patterns, like this is kind of what we do over and over again. It's typically historically done with topic models, right? You just produce lists of words, you produce clusters of vectors, and you interpret those. And those are somehow patterns and themes, and we often call those frames or narrative, but they're just clusters of words, right? So we see this, Andrea Voyer was looking at Emily Post etiquette manuals over time and how these manuals talked about immigrants, which was very implicit, but just list of words, right? And we see this with Pat Hastings and his colleagues looking at parenting logics, printing out lists of words, interpreting those lists of words. We see this over and over and over again. Goldenstein and Poshman again, printing out lists of words, interpreting those words. So allowing patterns to emerge from the data. But when you put words together in lists that you don't see paragraph by paragraph for qualitative social scientists, that can be a very, very powerful moment because it's hard. It's hard to read through text. But that's this is probably one of the older methods in qualitative social science. And then scholars use it to evaluate themes. So going back to Monica Lee and John Levy Martin, Monica Lee had a hypothesis. She's studying the Frankfurt School of social science, and she had a theory that Honneth was the true heir to the Horkheimer-Adorno Frankfurt School and not Habermas. So Honneth was Habermas' student. And people had been claiming Habermas was the heir, and she said, no, it's actually Honneth. He went back to the original kind of critical school around Habermas's back. So she was trying to prove this claim, and so she just laid the semantic networks on top of each other. She said, what is the overlap between Honneth and Habermas, Honneth and Adorno and Habermas? What is the overlap between Honneth, Adorno, and Adorno and Honneth, and Horkheimer, Adorno, and Habermas, and showed that Honneth had more overlap with the original one using these semantic networks. So you have a hunch, you use data to kind of evaluate whether your hunch is correct there. I mean, we see this a lot with the current kind of supervised machine learning, and in this case, this was a Roberta model, so transfer learning. So Bart Bonikowski, Liu, and Stuhler, I don't think he's here, they wanted to identify populism in speeches, which is a really, really hard concept to define. How do you know populism? Well, you know it when you see it. Can we make that more clear? So they hand-coded populism. They used a Roberta model to try to identify it. And where the model didn't match up, wasn't able to identify themes, they said, we need to update what we think populism is. So they used that moment of friction where the machine was not recognizing their concept of populism to update their own concept and define it in a way that was more clear. And JP used this kind of as well when thinking about how his claim was that the disciplines are getting closer together in Britain as they follow this very rigid standard of reporting, and use computational methods to kind of refine what it means for disciplines to converge. Like, what are we measuring there? Refining concepts. So we're getting a little bit deeper and a little bit closer to ontology now. So Alina Arsenyev-Kohler and Jacob Foster, they have a paper where they said, how does the machine know what it means to be fat? Overweight, fat. And their claim is we can actually refine what we mean by culture and schemas and having a cultural association between being fat and lazy or whatever, using computational methods. So they thought about word embeddings, the distributional hypothesis, as a way to actually define how people learn cultural associations. So I'm going to go a little bit deeper into this there, but it's really about thinking about these slippery concepts like cultural learning. How do you define cultural learning? How do you not even measure it, but how do you define it? And it's that moment that's really powerful. Maria Toniak and her group did this with narratives and stories. How do you know when something is a story versus not a story? This is actually really hard to define what a story is. So they attempted to do it computationally. Can we break it down into its constituent elements and be able to have a machine say, yes, this is a story, this is not a story? Back to Mattson and his team's work, they did this by trying to use a supervised machine learning algorithm to predict the emoji response on Facebook posts. And then they had humans do it. So they set up this machine where you could predict what the emoji response would be to a Facebook post. It got it right about, both humans and machines got it right about 50% of the time, which caused them to say, maybe there's not a cultural association between emojis and what we think of a real culture there. So they just rethought the idea that these emojis are a cultural artifact that you can measure and said, maybe not, maybe something else is going on there. So really challenging the way we think of concepts that we've been using for decades and decades, like cultural and schemas and learning and stories, and trying to force ourselves to rethink those concepts. The big animating question here that people get really upset about is what's validation, human or machine? If the machine can't recognize your concept, does that mean your concept is bad, or does that mean the algorithms are bad? This is almost unanswerable, so this is what we need to decide. I know that my concept is good, and I'm going to work until I force the machine to be able to recognize it, or just say that machines aren't nuanced enough to recognize it, so there it is. Or I'm going to take seriously that moment that machines can't recognize my theme to really rethink what I'm talking about. I don't have an answer. The field doesn't have an answer, but it's an important moment for all of us to think about. Lisa Argyle referenced this in her keynote yesterday. Like, is it because the LLM is just not good enough, or is it because we're not defining our concepts, or we don't have a concept that's good enough? How do we decide that? People will come down on either side very strongly sometimes. Synthetic data, I'm actually not going to talk about right now. I'm going to punt that to the future because I don't think we're ready for that yet. But I'm going to go, I'll come back to it. We're just not there. But I do want to talk about ontology because I think this is some of the deeper, more powerful moments. The reasons why I initially titled this talk, Why Qualitative Methods Need Computational Social Science. This is why I think qualitative methods need computational social science, because it forces us to define our ontology in ways that we haven't been faced with before. And it really puts it in front of us. And I appreciate the computer scientists for forcing us to do that. And so one of the early attempts at this was Jacob Foster's work in Poetics, where he said, what is culture? And he again used computational, the way computers kind of parse text. This was before the distributional hypothesis was popular, but he used these causal chains of computational methods to say, what even is culture? Anthropologists use this concept, sociologists use this concept, humanities use this concept. We cannot agree on what the concept is. So he tried to really bring some computational thinking to that. This is really important right now, because in the computer science fields and LLMs, they're trying to talk about cultural alignment, and they're trying to measure cultural alignment, and nobody can tell them what culture is. We have been here for decades. They should come to us and we should say, this is culture. This is how you measure cultural alignment, and we have no idea. So they proxy it with country, right, which they know is a terrible proxy for culture, but what else to do? So this is a moment where we could be stepping in and saying, this is what culture is. If we want to have cultural alignment, if you believe that's something that we should be trying to achieve, we need to be able to define culture in a way that's accessible to a computer here. They did the same with schemas. How do people learn? What are schemas? So schemas are the way that we interpret things, the world. What is a schema? Nobody can agree on what a schema is. And so we can really find it in our brain almost in a way using computational methods and really thinking about what are the way schemas function, and force a clarity on that, force a definition that we've never had to deal with before. And then what is society, right? We have actor network theory, which is really quite popular in Europe, and thinking about what society even is. And this is important now because ChatGPT is part of society, and so we can talk about what it means. Algorithms have been for decades, right, part of society, but now it's in a way that's a little bit stronger now, and we can think about qualitative methodology or qualitative theory, in this case, Bruno Latour's actor network theory, to just think about what society is in the place of non-human actors in society in a big way. We get back to kind of the original question here, back to the epistemology. Is the machine replicating human intelligence, or is it an alien thing? Does it process things differently than us? Because this is a really deep question. I know what's going on in AI right now. What is general artificial intelligence? How do we measure intelligence? But it's something that nobody in the qualitative social sciences can agree on. Are we just expanding our own intelligence and doing things better? Or is it really a fundamentally different way of processing data? And that can be a very powerful moment. So I want us to just present that as a question to have us all think about. But I think it has deep implications for the way we use these methods and what we claim they can do or can't do. And especially with large language models, as Lisa Argyle talked at length about yesterday. What are they doing? Are they replicating humans? Are they not? That's a really important question, and I have a strong opinion on that, which I won't present here. Okay, the future. So there's lots of exciting things happening, I think, in qualitative computational methods. Step one would be deciding on a phrase, a name for this subfield. Is it computational qualitative? But anyway, synthetic data, I think, belongs in the future because we haven't quite figured it out yet. So I'll talk about that. I think that counterfactuals are very exciting potential for the future. There's some generative potentials for qualitative social science. And then I invite us all to think about other possible futures here. So synthetic data, we're using AI to do interviews now, so that's big. There's actually an ongoing AI-led interview, I think, happening right now at this conference. You can find the QR codes where you'll chat with an AI bot about the future of computational social science. The ones that I originally, there's many papers. This is just one, Chopra and Holland. The graph here, the red means that the interviewers liked AI, the blue means they didn't. So largely it was a very positive experience for the interviewers, but it was originally proposed as a way to scale up qualitative interviewing. This is economists doing this, saying, we can make qualitative interviewing on par with quantitative methods. We can do it bigger, we can do it faster, we can make it more generalizable. And qualitative researchers, of course, they panicked on Blue Sky and Twitter and said, that's not what qualitative interviewing is. The point is to slow down and to understand your interlocutor, your interviewee, and respond to them and have that interaction. And so there was a lot of clashing heads about this. But I think qualitative researchers are getting more into the interviewing space and saying, all right, how would we do this based on qualitative principles, not to scale up and make it quantitative, but to really improve that process, the really deep interpersonal process, which of course is going to make some people not happy as well. But that's happening. I think we're going to continue to see that. And go take the AI interview here. We have simulations. Park and his big team, they did in-depth interviews of about 1,000 people and then fine-tuned a language model based on those interviews to simulate digital twins, right? So you have 1,000 digital twins based on real interviews, and then you can unleash them and do all sorts of experiments that you can't ethically do on humans, or you can't do it for any cost. And you can test out, you can provide some evidence to policy, right? So if we make this policy change, how would our simulations play out? And then you can have some sort of evidence where before you couldn't have any evidence. Is that qualitative? I don't know, but I think qualitative social scientists can weigh in on this idea of simulating or digital twins and what that gives us. And Lisa Argyle, I'm going to come back to her often. She showed this with her in silico sampling, where you can give a LLM a persona. You're extremely conservative. How would you answer these questions? And that again opens up all sorts of possibilities, right? And we're seeing, I think, a lot of simulations here at the conference today. Counterfactuals. So Tom Davidson published a piece in Socius thinking about generative AI, where he said, all right, social movements, right? This was the 2016 women's marches where they knitted those, feels weird to say this on stage, pussy hats. And it was these peaceful protests. You would never see this in real life. You would never see women marchers surrounding a burning car. But we can simulate that now. And that can be very powerful to simulate this in front of to our interviewees, to people, and say, here's a counterfactual that cannot and will not ever happen, and how can that help us understand what the world is? And I'm thinking about doing this with Ted Underwood, or we're trying to, and Matt Wilkins using history. So we built a GPT-2 size model trained on data only up till 1914 to think about the possibility of counterfactuals in history. History only happens once. We can't redo it. What if we could redo it? What if we could redo it thousands of times and use simulations to simulate 1,000 possible histories to think more about the history we got and not the history that we didn't get? Why didn't we get the history doing it? Lots and lots of problems here. I don't know how to do this. We tried with GPT-2, which is absurd. It produces absurd output, but that's what we're thinking about, is simulating history. And then the generative moment. So Philip Brooker here, back in 2019, he made a bot where he just kind of pieced together pieces of his own social media history. It's not generative, but he put that bot out into the world just as this playful thing to see how people responded to this bot and just watched it happen. But the idea is that bots are everywhere, right? Bots are interfering good ways and bad ways with our world, right? We ask Siri when we want an airline refund, we talk to a bot. And so the idea is that social scientists should be designing these bots. And so we should be experimenting with bots as we do that. And we see this back again to Lisa Argyle's work, if she's here. Thank you, Lisa. Looking at how bots can interfere in polarizing social media moments. So when conversations are getting out of control and polarized, can we insert like a bot into it and cool things down? And they find yes. This is done in a quantitative way. I think qualitative sociologists can really think about how we might use bots and generative moment in our own research, which was more the kind of spirit of Philip Brooker's work way back in 2019. He's ahead of the game there. So the question here, and I think this is certainly an and, right? We've been modeling society, we've been describing society for decades and decades. Can we generate society, and what is that moment giving us? And that's, I think most of us are grappling with that right now. So how is that different? I think it truly, genuinely is different than what we've been doing, and that's potentially a very exciting moment. Okay, so qualitative computational methods. We're drawing from epistemologies. Ideally, we should be having an epistemology that determines our applications. These are not matching, by the way, the rows. They're just lists to apply our epistemology. And then I talked about some possibilities for the future in the generative moment, encouraging us all, because most of us are doing qualitative social science, to make it explicit when we do that. Thank you.
Thank you, Laura. Very thought-provocative, lots of questions, very good lecture. So do we have any questions? By the way, before we start the Q&A, can we have the speakers for the lightning talk slowly move to this side of the podium? But we'll take questions also.
Thank you for the fascinating keynote. Super interesting. Love the hot takes. My question is for computer science. It's struggling in many ways with these questions of like meaning and interpretation. So what comes to mind is benchmarking and evaluation.
Yep.
And a lot of this is like social science. We have a hypothesis, we have like a regression we want to test or something, answer a social question. But I wonder what you think of this, like some people have called it the evaluation crisis happening in benchmarking, and whether we can like bring these ideas there to help them or help us with that problem.
Yes, I think benchmarking is one of the major problems for large language models right now. And in particular, when people are computer scientists are trying to define bias or measure bias in both, like, okay, we need to correct for bias and to make sure a bot doesn't refer, I don't know, like wine to the wrong person, right? Who's gonna be offended about drinking wine. But they can't define culture and they don't know how to benchmark culture, and we don't either. That's the problem. It's like we don't really have a good solution for them. There's a great paper by David Baman is, I think, the senior author, where they're trying to kind of articulate what the different dimensions of culture are, because it's not just one dimension. And so that's like the best attempt I've seen to try to say, here are the two different dimensions of culture. So we can talk about dimensionality. It's not just one dimension. It presents itself in different ways. I think this is a good moment for us to define our terms and say, this is like, we need to be better at defining what we mean by culture and schemas and how we would benchmark them. And it can't just be like question and answer pairs. It can't be law exams. It can't be math tests. It's something much deeper. And it's not just human annotations either, right? A lot of if you're looking for funding, because the funding landscape has collapsed in the US, a lot of the foundation fundings are looking at this question in particular, is how do we benchmark in ways that aren't the kind of standard benchmarks? So it's a good space to be in. I just don't feel like we have our house in order enough, but this is our moment to get our house in order and weigh in on those conversations.
I see a hand over there. Wait a second.
I can use my outside voice. So for the question of validation,
Yeah.
are there good examples of concepts that can be coded with high reliability by human coders that LLMs can't capture?
Yes.
To me, a lot of times when LLMs can't capture it's because human beings can't either. It's just not all that coherent, or it's extremely subjective.
I mean, that's the debate. This is the not pushback, but this is the kind of conversation that happens, right? Is like some people say, well, LLMs can't. The concept is fine. The concept is fine, and humans can agree on it, but LLMs aren't there yet because of various reasons. We know that LLMs are trained on a very small subset of human-produced data, not the full world. They, of course, don't have the physical experience of bumping into things. So we bring an embodied viewpoint to our way of coding things that LLMs, at least right now, don't bring. And Catherine Hales talks about this as the fragility of reference. And so for some people, that fundamental difference between the embodied nature of the way we approach a coding task and the disembodied nature of the way LLMs do means there are some concepts that we can define that LLMs won't ever be able to recognize. But we're dealing with intercoder reliability around 0.6, right? That's good. If we can get intercoder reliability at 0.6, 0.65, we're like, great, this is good. That's terrible. That's terrible, right? So yes, we don't agree on it, which is really why I think we should push ourselves more and say, why are we accepting this? As like experts agree only 60% of the time, more or less. I know the calculation is different. I don't think that's good enough, especially when we're dealing with benchmarking, especially when we're dealing with these very deep questions, when these LLMs are being put into practice to recommend resumes and jobs. These are important moments, and I don't think 0.65 is doing it. So I think we really need to reconceptualize how we're thinking about these concepts, and when we can't even do it as a human, we should think about what we're doing. I don't think we should be accepting 0.65 as like an acceptable intercoder reliability, which might mean we can't measure everything we want to measure, and that's fine. Some of the stuff can just be interpretive, qualitative. Humanities are great, right? We can go back to that. It's fine. We don't have to put numbers to everything. Not everything that's meaningful can be counted. Not everything that can be counted is meaningful. Blah, blah. But yeah, thank you. That's the exact debate, and I think it's one that we should be talking about more.
Yeah, thank you very much for this fascinating presentation.
Where is this coming from?
I was wondering, one of the last questions that you raised, one of the last questions that you raised was whether we should model or generate society. Could you elaborate a bit more on that?
People are thinking about what is new about this current moment with LLMs, right? Is it just machine learning, but bigger, deep learning, more layers? But it's not, right? The generative moment is truly fundamentally different than what we've seen in the past. And so we should, of course, never give up modeling society. That would be absurd. We'd be in science fiction territory, like right away, right? So we shouldn't ever give up staying grounded in the data, making sure that we're tethered to reality. But at the same time, like this is truly a new moment for us where we can generate stuff. And so this actually gets back to pragmatism. I think this is the moment for pragmatists to shine, where they say, when we put this into practice, as in we insert it into real conversations in social media, we put it in a subreddit, we recommend resumes, we recommend jobs, right? These are being put into practice in a way the pragmatists need to come in and say, now we can think about when it gets put into practice and your resume recommendation system only recommends women. This is our moment. Sorry, only recommends men, which has happened. This is our moment to say, like, all right, let's talk about theory. That was a weird mistake. But yeah, so the generative moment is being inserted into reality. It is shaping the world right now, and so we can't back out of that. So we should always be modeling. We should always be in the data, but we would be remiss and we would be doing a huge disservice to the world. And Lisa Argyle made this point yesterday, if we ignore the fact that these generative models are being inserted to the world right now and we don't understand the full implications of that. So we must generate society to understand how that works. It also will help us understand society better, honestly. If forget about the real world, we can actually make interesting progress. I mentioned the historical case, right? That's not a practical case where that would have any implications, except we might understand history better. So just understanding history for the sake of understanding history, I think, is also a powerful moment. But don't give up modeling society.
Thank you very much, Laura. My question is that if you believe in ethnography of machine, and by that I'm also inviting you maybe to share your opinion about that question, machines as human or aliens.
We need to be doing ethnographies of machines. Just as I was saying with the LLMs that are being inserted into reality, we need to understand what machines are. we can understand them technically, right? What are the different layers and how are they influencing? But we can also understand the interplay with reality. And that's not new. We've been doing digital ethnography where we look at social media spaces. Europe is much better at this than North America, I think. We should be treating machines as aliens, not as a way to understand society, but as an actor in society, as an alien actor, a non-human, I shouldn't say alien, a non-human actor in society. And we have the frameworks to do that. And we need to be doing much, much more of that, I think. So digital ethnography, did you call it machine ethnography? That's cool.
Maybe I can elaborate.
Yeah, please. Yeah.
Yes.
The most computational of social scientists benefit from their lived experience as humans, and we rely on whatever we have observed on daily basis. When it comes to machines, we are lacking that, obviously. So my question is that whether ethnography fails if we are using those methods to study machines in isolation or group of them.
You know, that makes me also think we need to reflect more on our lived experience. I don't like that phrase, but lived experience as we use machines. Like an autoethnography almost, which is another controversial thing, but which I think the anthropologists are doing. I think that's what they're doing. They're using, I'm seeing a lot of this come out in Acta Sociologica, where anthropologists are using these, usually generative, but using machines and then reflecting on their experience and how it changes them. I see that mostly coming out of like University of Copenhagen, but it's really great work. And so I would think, is your team doing some of that? Yeah, okay, your team as well. Really awesome. So just use it. So anthropologists are just using this and treating it as an ethnographic field site, which is a very powerful moment. So I was told that there's not many anthropologists in Europe, that you don't get trained in that, but this is really neat stuff, is just use it. Just use it and see, and then treat it as a field site. 100%. I think that's great. Thank you for that.
So we still have time for one question, because Laura has been speaking at twice the speed a human can speak. So
Sorry.
no.
Fucker.
Any other questions? We can take one more question before we move on to the lightning talk. Oh, go ahead. Any mic?
Hi, thank you very much for the inspiring talk. So at the end, it was super fascinating to hear the application of GPT to simulate alternative histories.
Yeah.
And I wonder if you have something to tell us about how this could help, if it could help with imagining alternative futures, which is something that has been in the talk a lot, Mark Fisher and so on. And the difficulty of the present moment, maybe this can help.
I think it can be both used to imagine possible past, which science fiction writers do all the time, and dramatists, and imagine for possible futures, or different possible worlds, even not just futures. So do we live in the best of all possible worlds? Probably not. We don't, right? So could we simulate a better world and think about what that would really look like? And that means, like, if gender stereotypes never existed in language, we've never lived in a world where gender stereotypes aren't deeply, deeply embedded in the language, and that really affects the way we process the world, like at a fundamental level. Could we simulate a world? What would it even look like to not have gender stereotypes deeply embedded in language? That's an exciting moment, right? It's probably never existed, at least not in recorded history. Probably won't exist for a long time, but simulating that and presenting to us like a world that exists, that is exactly what I'm thinking. So the picture of the Women's March in the front of the burning cars is one, but that's another one, is like, simulate discourse where gender stereotypes don't exist. Let's do that. And what does that tell us about the current world? And then if we want to get to that world, how long would it take us, right, if we use these simulations? That's the potential power, but there's all sorts of validity concerns, all sorts of, like, let's not get into science fiction territory. So there's a lot of steps, but that's what excites me. Absolutely. I think very much.
All right. Let's give Laura another round of applause.
Thank you.
Thank you.